Hello everyone. Hi. I'm audible. Is the audio okay? The audio okay? Yeah. Good evening everyone. I'm Rahul Mohnani, your maths educator. You can use my code RMSir to take any ISC plus subscription for class 11 or class 12. Today's topic that we are going to discuss is integration. Okay. In the previous session we have covered the algebraic integration, algebraic types. That is, I think we have covered linear by linear, linear by linear, quadratic by linear by quadratic, quadratic by quadratic. These type of questions that we have covered, algebraic questions, in the previous session. Today we are going to cover some questions which are based on trigonometric type. Some questions which are based on trigonometric type. In this, initially the question will be in trigonometric format, but after substitution or after conversion, it will get converted into linear by linear again. It will get converted to linear by linear again, or linear by quadratic. It depends upon the type of question. Okay. So I'll solve up to a particular stage. After that, you can solve it by the previous method which I've taught in linear by quadratic or linear by linear format. Okay. So initially I'll take the easy questions, and then slowly we'll take the different level. So let's start with the first type. First type is of integration of a sin x plus b cos x plus 1 plus c, not 1, any constant can be there, plus c. This is 1 upon linear in trigonometry, and trigonometry also considers sine and cos only. This is 1 upon linear in sine and cos, a sin x plus b cos x plus c, like that. So in this, what exactly you have to follow, or what is the procedure? Procedure is, instead of sin x, you have to use this formula, 2 tan x by 2 upon 1 plus tan square x by 2. This was the half angle formula that you must have learned in the class 11. 2 tan x upon 1 plus tan square x by 2. This formula you have to use instead of sin x. Instead of cos x, you have to use 1 minus tan square x by 2 upon 1 plus tan square x by 2. This is a half angle formula for cos x. Okay. So while using this formula, the entire question will be converted into tan, because we have substituted the formula in terms of tan. Now there will be a stage in which you have to keep tan x by 2 as t. After simplifying, you have to substitute. These are the steps. Okay, these are the steps. There will be a step in which you have to use that formula, tan x by 2 as t. Okay, if tan x by 2 is t, then the secant square x by 2 into derivative of 1 by x by 2, that is 1 by 2 dx is dt. This you have to use it. Okay, initially it might seem difficult, or you might be not getting this part, but once I'll write a question, okay, then you can easily start, or you can easily understand the question. So the first point is, substitute sin x as this. Just a minute, need to just a minute. Okay, Yeah, I'm sorry. So you have to use, the first step is, instead of sin x, use 2 tan x upon 1 plus tan square x by 2. Second, instead of cos x, use this second formula. And then the third step will be tan x by 2 is equal to t, and then secant square x by 2 as a derivative part. Okay, this is a connected one. Let's take one question. I hope you understand. You have to find the integration of 1 upon 2 plus sin x dx. This is the basic question I've taken. Integration of 1 upon 2 plus sin x dx. Instead of sin x, you have to put 2 tan x by 2 upon 1 plus tan square x by 2. Okay, so question will be something like this: 1 upon 2 plus 2 tan x by 2 upon 1 plus tan square x by 2 dx. When you simplify this part, I mean this bracket, you'll come to that 1 plus tan square x by 2 will be in numerator. 1 plus tan square x by 2 will be in numerator. This will be 2 cross multiplication, okay, LCM type. 2 plus 2 tan square x by 2 plus again 2 tan x by 2. This one, fine. So we can take 2 common afterwards. This is what we have. Now here, if you can observe, in numerator 1 plus tan square x by 2 is there. That can be written as sec square x by 2. And from denominator you can take 2 common. Okay, so 1 plus tan square x by 2 plus tan x by 2 dx. I hope this is, till now everything is simplification part, like every step is to simplify just by substituting this formula. Okay, if simplify karna hai, cross multiplication, division, multiplication, like that, using this formula. So here we have reached in the terms of tan and sec, and now at this step you have to put tan x by 2 as t. Now at this step you have to put tan x by 2 as t. So this entire question will get converted into, I'm writing it over here. Okay, if tan x by 2 is t, then sec square x by 2 into 1 by 2 dx, that is dt. Sec square x by 2, okay, 1 by 2 dx, that is equal to dt, and that we are converting over here, and the result is integration of dt upon this tan square x by 2. Look at this point, this tan square x by 2 will be t square, tan x by 2 will be t, because we are substituted tan x by 2 as t, because we are substituted tan x by 2 as t. So this entire tan square x by 2 is t square. Then this will be t, and this will be 1. Okay, and now this got converted into 1 by quadratic. From here, linear type that we have discussed in the previous session. So hopefully you have watched that session, because if I am going to solve the entire question, we will not be able to cover the remaining parts. So from here it is 1 by quadratic type. In the previous session I have converted, I've taught this type of questions. You have to make the perfect square and all. So do watch that session before this particular trigonometric part. Okay, algebraic part is more important, because anyhow trigonometry is converted into the linear, the quadratic format, the algebraic format. This is not linear, sorry, this is quadratic or algebraic. So in the previous session we have learned this part. Okay, I'll just brief this part again. A sin x plus b cos x plus c, whatever the constant, like in this we don't have a cos x ka term. If cos x was there, then thoda और lengthy hota. Cos x ka bhi we used to have the फॉर्मूला, देन ऐसे पूरा सॉल्व करना पड़ता है. ओके, दिस वाज द पार्ट. सेकंड टाइप, second integration is of this type. 1 upon a sin square x plus b cos square x plus c cos x sin x plus d dx. So out of this three terms, sin square x, cos square x, any one can also come, any two can also come. There is not compulsory the entire terms will be coming. Like for example, in this we have kept three terms, a sin x, b cos x and c. Out of these three, only these constant term and sin x term came. है ना. ऐसा कंपलसरी नहीं है कि पूरा ही बड़ा क्वेश्चन होगा a sin x plus b cos x plus c. ऐसा कुछ कंपलसरी नहीं है. उस पैटर्न में लाई कर रहा है. दिस पर्टिकुलर क्वेश्चन इज ऑफ दैट टाइप, जिसमें ट्रिग्नोमेट्री में वी हैव अ लीनियर टर्म of sine. A question can be of this type also. If I am writing over here 1 upon 2 sin x plus cos x. Okay, this is also a type of question. Okay, 1 upon 2 sin x plus cos x, any linear type है ना, sin cos में. Similarly यहाँ भी कोई quadratic type आएगा sin cos में, and also sin x cos x thing. Okay, in this the procedure is divide numerator and denominator with cos square x. Divide numerator cos square x. In this what will happen, like convert the entire denominator in tan. Convert the denominator in terms of tan and then put tan as t. In the previous pattern, tan x by 2 was substituted as t. In this you have to put tan x as t. In this you have to put tan x as t. Now I think let's take one example. Okay, integration of dx upon 3 minus cos square x. Okay, 3 minus cos square x dx. Now if you are dividing numerator and denominator with cos square x, or if you want you can do one more thing. We can take little lengthy question. So it is, let's say 2 cos square x plus 3 sin x cos x. Okay, this one 2 cos square x plus 3 sin x cos x. We are going to solve this question. Now in this divide numerator and denominator with cos square x. So when you divide numerator may we have 1. So 1 upon cos square x is what? Sec square x. If you divide numerator and denominator with cos square x, we'll just write it over here. Okay, so 1 upon cos square x is sec square x dx. This whole upon 2 cos square x upon cos square x is 2. 3 sin x upon cos square x will be tan x. Now this becomes very easy one now. When you divide numerator and denominator with cos square x, 1 upon cos square x is sec square x. This is 2 cos square x. If you divide, it gets cancelled. So 1. 3 sin x by cos x upon cos square x, it is tan x. Okay. Now you put tan x as t. You put tan x as t. So if you substitute tan x as t, numerator derivative, that is sec square x dx, will become dt. And now the question becomes dt upon dt. And here it is a 1 upon linear type. The answer is log of 2 plus 3t whole divided by 3 plus c. And instead of t, we'll again substitute tan. So 3 tan x plus 2 plus. This is your final answer. Okay, this is the final answer. Done. Okay, so this was the easy. All you have to do is just understand the steps, or what is the initial step, I can say. Okay, एक बार steps पता चल जाए starting के, so all you have to do is follow those steps and get the answer. न्यूमरेटर को cos पर से डिवाइड करना है, डिनोमिनेटर को cos पर से डिवाइड करना है, convert the denominator in tan x and then put tan x as t. This will help you to solve the entire question. We'll take one more, okay, based on the same pattern. Integration of 1 upon 4 plus sine square x dx. Okay. 1 upon 4 plus sine square x dx. Now to solve this particular question, again we observe that denominator में sin cos में square है. Okay, just by observing you can say sin square है, cos square है, sin x cos x, like this. Okay, so when I observe here sin x cos x है, cos square x है, so first step is always this: divide numerator and denominator with cos square x. Okay, so here also divide numerator and denominator by cos square x. So when you divide this by cos square x, in numerator you observe sec square x because 1 is there. This will be 4 sec square x and this will be tan square x. You divide each term with cos square x dx. Now sec square x, 4 sec square x, it is 1 plus tan square x plus tan square x dx. Instead of sec square x we have written 1 plus tan square x. So what is the target? To convert the entire denominator in terms of tan. As we have mentioned over here, convert the denominator in terms of tan. This is, I should mention here, in terms of tan. In terms of tan x. Okay. So this is 5 tan square x because 4 tan square x and plus 1 plus 4 dx. Okay. Now here we will substitute tan x as t. Tan x as t. So sec square x dx will be dt. So the entire question now is dt upon 5t square plus 4. Dt upon 5t square plus 4. Now from here there is a formula. I'll write this on the next slide. I'll write this on the next slide. Okay. Hello Ayush. I just saw your comment. Sorry, I didn't reply over there. You're from which batch? Ayush Yadav. Which class you are? So the last step which we have got is what? 1 by 5t square plus 4. So let's take 5 common. 1 by 5. 1 upon t square plus 4 by 5. So if you can remember that there's a formula, I'll write it over here. 1 by x square plus a square. It is 1 by a tan inverse x by. So let's apply that formula here. 1 by a. 1 by 5 is already there. Fine. 1 by 5. This part is already there. Now 1 by a. 1 by 2 root 5. Tan inverse t by a. 2 by root 5 plus c. So this will be 2 root 5 tan inverse root 5 tan x by 2 plus 3. This is the final one. Okay, I think we have covered these two major types, one by linear in trigonometry, one by quadratic in trigonometry. Okay, now let's take the different format. It is something like this: 1 upon or a sin x plus b cos x upon c sin x plus d cos x, something like this. Okay, linear by linear in trigonometry. In numerator we have a linear terms in trigonometry, in denominator also we have a linear terms in trigonometry. So this part will start now. In this, the procedure is write the numerator a sin x plus b cos x in the form of denominator, so it can be like capital A times c sin x plus d cos x plus b times the derivative of denominator. Okay, b times the derivative of denominator. I'll take an example to understand better. Fine. So if possible, we'll write the numerator in different formats. Initially I'll take the easy question. And then the difficult one, or in which we have to solve a lot. Okay. Or we have a less time, so we'll directly start with the better question. We have to find the integration of sin x plus cos x upon 2 sin x minus 3 cos x. Let's say this is the question. Okay, it is little lengthy, but I'll solve up to certain stage so that you can understand. Fine, we'll go slowly for this particular question, so do focus on this properly. We'll write numerator as sin x plus cos x. Here we'll write capital A times denominator 2 sin x minus 3 cos x plus b times derivative of denominator, so it is 2 cos x plus 3 sin x. What is the plan? We are going to write this entire numerator. The left side is numerator. Okay, just a minute. The left side is numerator, this entire part is numerator. A times, a is the constant that we need to find. A times the denominator. Look at this entire denominator I've kept over here. 2 sin x minus 3 cos x. This entire denominator I've kept here. Plus b times the derivative of denominator. Okay, this is the pattern. This will help us to solve it very easily. I'll tell you how. But right now, let us finish this part first. So 2 sin x, 3 cos x का derivative I've kept here. Derivative of 2 sin x is what? 2 cos x minus 3 sin x is plus 3 sin x. Derivative of this part. Okay. Now just let's analyze the coefficient of sin x on both sides, on left hand side and right hand side. So here we have only one sin x, like 1 times sin x. Here we have 2 times a, 2a sin x. Look at this properly. When you multiply a inside the bracket, you will have 2a sin x. How much sin x do we have on this side? How much sin x do we have on this right bracket? 3b. We'll have 3b sin x. Okay. Now, how many cos x do we have on the left hand side? 1 cos x. And in this bracket, we have minus 3a cos x. And here we have 2b cos x. So, this is where we have to solve the equation now. This is where we have to solve the equation and get the value of a and b. Okay, and get the value of a and b. So let's multiply this equation with 3. So I'll get 3 is equal to 6a plus 9b. Multiply this equation with 2. So I'll get 2 is equal to minus 6a plus 4b. Now add this, we'll get 5 is equal to 13b. So b is 5 by 30. B is 5 by 30. Now let's substitute b here in this equation and obtain the value of a. So 1 minus 2b, 10 by 13 is equal to minus 3a. So 3 by 13 is equal to minus 3a. A is minus 1 by 13. So this is the value of b, which is 5 by 13, value of a, which is minus 1 by 13. Now let's substitute here in this particular step, a and b. It means numerator is written as a times, which is minus 1 by 13 times this, and b times the denominator का derivative. So we will write on the next slide. Integration. Sin x plus cos x, which is numerator, is written as minus 1 by 13 times 2 sin x minus 3 cos x plus 5 by 13 times 2 cos x plus 3 sin x. Okay, this is what the numerator is, and in denominator we have 2 sin x minus 3 cos x. Now let's separate the denominator. Okay, now let's separate the denominator. You will get minus 1 by 13, denominator gets cancelled, plus 5 by 13, here we will get 2 cos x, 3 sin x upon 2 sin x minus 3 cos x. Now this part is easy to solve when you separate the denominator. So for this particular part, you will have minus x by 13 as the answer, and for this part, as we see that derivative of denominator is there in numerator. Okay, derivative of denominator is in the numerator, so we'll just write log of this one, log of 2 sin x minus 3 cos x. I hope you understood this particular question. Hello Akash, hi. Okay, so this was the third major category we have covered today. This was the third major category. Okay, hopefully all three you have understood. Practice a lot on this. If you still have a doubt, I'll recommend you to get a ISC Plus subscription, because there we have a doubt clearing session also. Okay, ISC class 11 or 12. You can use my code RM sir to get the subscription. You can get a 10% off straightforward, and you can enjoy the benefits of the plus. Okay, doubt clearing sessions भी होते हैं. You can easily ask your doubts whatever you have for any of the grade, ISC 12, 11 or anything. Okay, I'll end this session now. Bye bye. I think we should end this.